I appreciate it, Stephanie. Again, my name is Jared Duke. I'm with Optimum Seismic. And today we're going to be talking, well, first of all, we're an engineering and construction firm, and we focus primarily or almost exclusively on seismic retrofitting of existing structures, older structures that might be vulnerable to potential collapse in an earthquake. And so what we're going to be talking about today is basically going over an overview of a few different building types that have these vulnerabilities so that you can better identify them. And I'll try to cater this a little bit more towards, the way you might be able to use this information if you're brokering a deal or you have a client that's looking to invest in a property. We'll kind of talk about things in terms of what to look for in a building, how it's going to affect the value of the building, how you might be able to use this information as a negotiating tool and things like that. And along those lines, as that's not really my area of expertise, please feel free to ask any questions that pertain more specifically to how this information might benefit you at the end. We talked about this a little bit earlier, but if we can hold questions till the end, that would be great. I'm going to go over a fair amount of information, and some of it's going to be just in broad strokes. And if you'd like to learn a little bit more or go into a little bit more detail on things like the ordinances that are in place or the details of structures, please feel free to either type your questions in or we can take your questions directly at the end as well. But with that, I think we'll just go ahead and get started. This presentation is going to go over, like I said, a few different building types. And to start with, we're going to look at these steel moment frame buildings. So there are basically 5 building types that are identified as potentially vulnerable in the case of an earthquake and should be evaluated or are clearly vulnerable and need to be retrofitted in some capacity. These steel moment frame buildings are typically buildings that were built prior to the Northridge earthquake. So they're often referred to as pre-Northridge steel moment frame structures. These buildings, the typical fail point in these buildings is the connection points in the moment frame itself. So you can see on the right-hand side there a small version of a moment frame building. The connection points between the vertical beams and the horizontal beams is called a moment connection. And pre-Northridge, there are deficiencies in the way that they're connected in the bolting structure as well as the welding structure, which need to be identified and occasionally rebraced so that what you see here on the right doesn't happen on a larger structure like you see on the left. Another building type we're going to look at is the non-ductile concrete buildings, and these are actually extremely common in California, especially actually across the world. But the issue with non-ductile concrete buildings is primarily in the columns, like you can see on the right there. These are vertical columns. These are concrete columns with rebar reinforcing cages within them. The issue with buildings that were built before, and basically between the 50s and probably late 70s, early 80s, is the spacing of the rebar in these concrete structures leaves a lot of room for the concrete to buckle and crumble. And so these buildings are, like I said, very common. And there's a lot that you can do to reinforce them. But again, if you have any questions or you can identify these buildings as something that maybe you interact with commonly, let me know and we can go into a little bit more detail on those. Concrete tilt-up buildings are also extremely common. These are mostly warehousing or commercial structures. These are buildings where they cast the walls and the connection pieces on the ground and then tilt them up, which is why they're called tilt-up buildings. They're typically concrete walls. The issue with these buildings is commonly in the connection between the roof diaphragm and the walls themselves. It's very, very simple to evaluate these buildings. Take a look if they have sufficient connection points. What tends to happen when they start to shake in an earthquake is those walls start to separate, and commonly the roof will then collapse in. And we've seen this happen. Virtually every large earthquake in California has had multiple buildings like this collapse or have damage that's red tags a building and be completely rebuilt. And then the most common structures that are vulnerable are the URM buildings. I'm sure that everyone has probably seen these buildings around all over California, all over the country, really. But in California, there was an ordinance that was put into place in the early 80s to have these buildings retrofitted because they are by far the most vulnerable to collapse and really the most dangerous for occupants in an earthquake because there's so many shear locations and so much can potentially fall, collapse, and injure occupants. So what you've probably seen are braces, what look like bolts on the outside of these buildings, usually at every single floor line to tie the walls to each of the diaphragms. And then usually these buildings also have parapets, vertical parapets extending above the roof, and those need to be braced as well. So that's the most common that you'll see. A lot of these buildings, almost all of these buildings really in California have been retrofitted already. Most of them though would very much benefit from further evaluation and being retrofitted further or reinforced further to current building codes because previous building codes really only set the standards for minimum life safety to grant the occupants as much time as they could to get out, which is typically only about an extra 30 seconds or a minute, something like that. So these types of buildings should always be reevaluated for current standards to take a look at what's been done, make sure that the previous retrofits are still functioning correctly and nothing has been worn down or deteriorated over time. And those are the sort of what we were going to go over briefly, and we can go back to if anybody has any questions. But primarily, what we're going to focus on with this presentation are soft story structures. The reason that we're going to focus on these is that there are ordinances in place already and rolling out across the state, requiring that these buildings be evaluated and then reinforced. And each city will essentially decide on their own whether or not it's important to implement a mandatory retrofit ordinance or a voluntary ordinance. But eventually, all of California is going to address these building types because they're extraordinarily common and they're very easy to address. And they also typically are multifamily residential structures. So they house a lot of many people, and they constitute a huge amount of our affordable housing in California. So they're a primary target for resiliency sort of a movement. So in Southern California, Northern California actually was the first to implement any kind of an ordinance addressing these buildings, but Southern California, Los Angeles was the first. And since the Los Angeles ordinance was implemented in 2016, many cities have followed suit in the Greater L.A. area, followed by Santa Monica, Beverly Hills, then West Hollywood, and now Pasadena have all implemented specific ordinances addressing soft story buildings and requiring that they be reinforced by a certain date. These soft story buildings are sort of characterized by tuck under parking, like you can see on the right there. These are buildings with parking on the bottom floor and units living above the parking areas. The deficiency in these buildings is typically before 1978, the California building codes actually didn't require that lateral force resisting systems be incorporated in these buildings. So the columns that you see that are holding up the floor above are more than sufficient for the gravity load of the building, but when it starts to shake left and right, they just don't have the lateral force capacity to resist the weight above as it starts to move. So they tend to buckle and fall down either left or right or pancake down on themselves. And this is something that we saw especially, and this is really what triggered the ordinances, is in the Northridge earthquake. We saw the Northridge Meadow building collapse, which was a huge building, killed 16 people, unfortunately, and many other buildings collapsed in similar ways. There's a huge amount of property damage, huge amount of displacement, and it triggered sort of the slow process of the city employing various engineering firms, putting together an inventory of potentially vulnerable buildings, and then eventually coming to a conclusion, passing an ordinance to require that these buildings be reinforced so that when the big one comes or the next big one comes, we're not going to see the same level of disaster that we did in 94. So the purpose, just quickly, the purpose of the ordinance in Los Angeles and the surrounding ordinances is primarily life safety. So while these ordinances aren't focused on protecting the building and preventing total collapse or making sure that a building is not going to collapse, they're primarily focused on ensuring that if an earthquake does happen, the occupants of the building are able to vacate the building. What's great about these soft story buildings is that they're wood frame buildings, so they typically perform very well in an earthquake. They're very ductile, they're able to move with the motion. And absent of a soft story condition, wood frame buildings perform extremely well. And the retrofit of these buildings to mitigate just that soft story condition really does keep the building in, it gives the building the best possible chance. In most cases, you'll see that when these buildings perform once they're retrofitted, they can be reoccupied virtually immediately. Usually there's only aesthetic repairs that need to be made. Very unlikely that a retrofitted building of this type is going to be red tagged or inoccupiable after an earthquake. I'm going to go into just very briefly a little bit about how these ordinances are implemented, because as they start to roll out in various cities, they basically will follow the format of the original Los Angeles ordinance. And what they did with that ordinance is essentially create an inventory of all vulnerable buildings and then send out notifications to owners of each of those buildings, letting them know that that their building has been tagged. It's potentially a soft story structure and needs to be addressed. And what they said was, we've given you a certain timeline and certain deadlines that need to be met progressively. The first deadline is to have the building evaluated, submit a set of plans to the city for the retrofit. Actually, let me slide here, it'll be a little bit easier. Start with you, they given building owners 2 years to either provide proof of a previous retrofit, provide plans for a retrofit, or plans to demolish the building. So that first 2-year deadline, if you're able to show that the building does not have a soft story condition, then it will be removed from the inventory. But otherwise, within 2 years, you need to have a set of plans generated by a licensed engineer, submitted to the city so that they can go through a plan check and be approved for construction. They've given a second deadline of 3.5 years to actually pull a permit and 7 years in total to complete the work. The following cities in Santa Monica and Beverly Hills, each city has a different timeline, a different schedule. Usually it's based on the number of buildings they have that are potentially vulnerable. Los Angeles has about 20,000 of these buildings, so they triaged out their orders to comply accordingly. Let's see, how do I go back? So they started with buildings with 16 or more dwelling units. These buildings that have, occupy the most, have the most occupants, followed with buildings that were 60 units or less, and then sent these notifications out to the following buildings that, will house fewer people, so that they're not going to be overwhelmed. But in other cities with a smaller number of units, their timelines are much more stringent. Beverly Hills, I think, 3 years total to complete the entire project. They need to have plans submitted within 6 months, and things like that. But essentially, the structure of the ordinance is always the same, and it's going to be adopted and vary city to city. What's important about these ordinances is that the actual work, it does not vary. It's all based on the same California existing building codes, and so any work that's going to be done outside of an ordinance, say in a city that has not yet adopted an ordinance, and they adopt an ordinance later, you'll want to address these items per the current building code, so that once that ordinance is implemented, you're not going to be forced to do any further upgrades. And then, of course, along those same lines, there are a lot of great reasons to reinforce these buildings outside of an ordinance. Of course, you don't really need to wait until you're being forced to do something like this by the city. There's, of course, an economic incentive to do something about your building. You want to protect your investment to the highest degree possible. We know we live in earthquake country, and it's going to happen. You never know where it's going to hit or when, of course, but if you know you have a vulnerable building and it's an asset of yours, it really does make a lot of sense to protect it in every way possible. Earthquake insurance is one way to go, but of course, these preventative measures are going to be the most cost effective, have the best cost benefit ratio, because of course, earthquake insurance will only pay out so much. You of course have a deductible, and preventing the building from collapsing in the first place is, in our opinion, the best possible way to go. We are seeing in cities as well that don't have an ordinance in place currently, that many lenders are requiring that this work be done before a loan can be finalized. So if you're going through any refinances, many Fannie Mae loans are requiring this work be done, and things like that, as well as insurance companies. Some insurance companies won't re-up an insurance policy at all, or especially an earthquake policy, unless these conditions have been addressed or mitigated. And of course, there's the cost of these projects. Typically, generally speaking, the cost of construction and this type of work does tend to increase over time. And what we've seen, of course, when there's a city implements a mandatory ordinance, the demand goes up quite a bit, and the cost tends to increase fairly substantially. We saw a massive increase over the past 4 years in Los Angeles, the cost of these projects. 2016, they were fairly simple, easy to do. Usually you would see projects ranging from $30,000 to $50,000, and as time went on, as the ordinance actually morphed and changed a little bit over time, and the cost of construction tended to go up. The cost is essentially between $40,000 and $80,000 for most projects. It can be up to $120,000 or $200,000 for larger, more substantial buildings, which we can go into. I'm going to start moving forward a little bit quicker now, and show you a little bit of what these projects really look like. So here's a few different examples of soft story structures. They come in all different shapes and sizes, obviously, and I'm sure everyone here has seen these buildings. They're one of the most common structures for multifamily residential in California, for good reason. I mean, they're a great way to maximize the use of the space. They have parking underneath. You're able to use the space above for units. What we see here are obviously 4 different buildings. What you're looking at in terms of what constitutes a soft story condition is the open face. The top 2 and the bottom left photo there have one soft story line. So there's only one line of the building, one wall of the building that is potentially vulnerable to collapse. Whereas the bottom right building here, you see as a full cantilever overhang. What you'll see there are those three walls of the building. Each wall has its own technical soft story condition, and each one would require its own individual form of reinforcement. I'm going to go into a little bit of what that looks like. I'll try and be a little bit brief about it. But essentially what goes into a soft story retrofit is the installation of some kind of a steel moment frame or steel column. Always there will be an installation of new foundation, usually tied in with the existing foundation. There's work that needs to be done in the second story framing of the building so that all of the top story is tied together, and that energy can be transferred efficiently to the new column or the new system that's being implemented. Sometimes there's new shear walls that can be used, and I suppose, yeah, it's important to talk about the process in a little bit more detail. The process for approaching these projects is essentially twofold. The first stage of any of these projects is to have a building evaluated. Of course, you need to find an engineer who has some experience with this work to come out, survey the building, draft the building, perform some calculations, kind of understand what are the loads, what needs to be mitigated, and then come up with a design, submit that design to the city, go through a plan check process with the city to ensure you're meeting all the requirements of backup distance and parking regulations that each city has, so that you can receive an approved set of plans. So once you have that approved set of plans, essentially they're not going to change at that point. And so you take those plans and collect a few different bids for construction at that point. Find someone that you trust who's done this work before, and then don't base your decision on price necessarily. I would say base it on experience, but make sure that you have that set of plans approved before you collect bids so that you're comparing the scope of work correctly, an apples to apples comparison. There are a lot of ins and outs and question marks in these projects, so it's really important to have a set of plans to scope defined before collecting bids. Otherwise, there's really no way to judge one bid from another without knowing what's going to be required for retrofit. So The first stage of an actual retrofit, once plans are done and you've started work, is, well, let's go through it using pictures rather than. So the first week of these projects, these projects typically last, they're about 4 to 6 week projects, and they go in pretty distinct stages. So the first stage is to open up the building, expose all the framing of the building, do all of your demolition, excavation of your new foundations. You're opening up the framing of the building to see what the conditions look like. You're going to need to do your bracing in the framing of the building there. But once all of this excavation and demolition is done, you'll have a city inspector come out, take a look at what's there, because assumptions have been made during the engineering process. And so you want to make sure that all site conditions correspond correctly to the plans. And usually there are some minor revisions that need to be made based on details of the framing of the building and the way that it's built. You also want to make sure that once you open everything up, you're not dealing with high voltage lines or gas lines and things like that. And those require minor revisions typically. The second week essentially of these projects is going to, well, this is every day you should be able to even clean and cover the site. This is important, sort of a caveat. We're always dealing with parking areas, almost always, 90% of the time. I'd say 98% of the time we're dealing with parking spaces with these types of projects. So it's really important to make sure that tenants have the ability to park when work isn't actively being done. So what should be done is any open trenches can be covered, like you see here with plywood, making sure that everything is covered flush so you don't have trip hazards and things like that. So these are high traffic areas. And so it's really important to make sure that tenants have a place to park, especially in LA. Parking is quite a premium. So whatever we can do to make sure that tenants are able to use the building, the building is functional outside of work hours is very helpful. But the second week of these projects is usually marked by the steel fabrication and installation. The steel fabrication is essentially, depending on the system that you're using, many of you have probably seen these projects if you've been through LA or the surrounding areas. Large moment frames, which look like upside down staples, which 2 large columns and a beam connecting across the top, or even just a single beam. These are structural steel I-beam columns and to be fabricated and installed. The third week, well, it really is the second week, the installation here. But the steel and rebar typically happen around the same time. It's really about week 2 that we're installing steel and rebar in the open trenches. These rebar cages constitute what's called a grade beam foundation, and typically there's also some doweling that happens to the existing structure so that the new foundation and the new poured concrete basically operates as an extension of the existing building's foundation. The pouring of concrete then happens. That really is probably week 4. And the final stage, of course, is the finishing work at stucco and paint to match. So you want to make sure that the building ends up looking about aesthetically as it did prior to the retrofit. So the bottom right there is a finished retrofit using a moment frame. It's reinforcing the bottom line of the building so that that left and right movement is going to be essentially transferred directly to that new column all of the way to the second floor, and the lateral energy is being transferred away from the existing columns onto the new existing system. It's just another image of a finished product. This doesn't really pertain so much, I think, to what you might be interested in, but there are, managing cost and risk in terms of what an owner is looking to do. The best way to do it is make sure engineering is done with someone who has experience with construction, so that they have an idea of how their design is going to be implemented and the constructability of the design itself. We always approach these projects in a design bid build process. But sort of mentioning is that engineering should be done. You should collect a few bids based on the same scope of work, and then commence the project after that. You should always be looking for fixed price contracts. You don't want to be subject to change orders throughout the process. Once you have a set of plans approved, you should be able to demand that any contractor give you a price that's not going to be subject to change, regardless of the minor details that might you might find on site when you open up the stucco shouldn't be significant enough to constitute a change order. You shouldn't have any surprises throughout the process. So make sure that you're dealing with licensed and insured contractors, both for the engineering and the construction process. Of course, you need anybody. You always check a license, make sure they've done these projects before, make sure they have a Class A engineering license, and make sure any contractor, of course, carries a Class B contracting license. And the proper insurances are key. You need to have general liability, workers' compensation, auto insurances, of course, and you should be able to also request that they give you an additional insured certificate, so that whoever the owner is of the building is going to be covered. Hazardous materials testing needs to be performed anytime you do work like this. If you're opening up stucco, you need to be checking for lead and asbestos prior to opening up. I'm just going to go through a few of these projects with you, just to give you a better idea of what the finished products typically look like. This is a fairly extensive project where significant lateral bracing needed to be installed so that the soft story line of the building, all that energy could be transferred back to the moment frame that you see there, because of the parking situation didn't really allow us to place that column in line with the second floor of the building. It would have meant that cars weren't able to turn and park in that area. So the circumstances that you're dealing with, the site conditions where the functionality of the building has a big impact on how the design is going to be implemented. So really important to have somebody who has some experience design these. It can start to get a little bit out of control if you don't know what's going to be required of you throughout the plan check process. You may have to go back and forth with the city many times before you land on a final design that's going to be accepted. So the more experience that somebody has, the better. This is a very large project. Actually, this is a great example of a value engineering project where this is a project where plans came actually across our desk. They had already been designed, but they were, they were fairly over-designed. That the original plans had multiple moment frames in multiple locations. There's actually another soft story line on the other side of this building. We actually were able to redesign this project with using a larger moment frame, special moment frame, a little bit larger drag struts and foundation, and we were able to actually save the cost of the project about $40,000. So it's pretty significant the engineering. Essentially, the point of what I'm trying to say is the engineering really drives the scope of these projects and drives the cost of the project. There are a lot of ways to reinforce these buildings. It's really important to approach them with someone who's knowledgeable about how their design is going to be implemented. Extremely important. This is the same building that we showed at the beginning of the presentation as the 3 soft story lines. This is post retrofit. You should be able to expect that any new columns and new installations should be framed around stuccoed and painted so that they match the building. It incorporates well with the aesthetic of the building. You can see that on the right-hand side of this building, there's a new column sort of pushed in the back and hidden inside the storage containers there. There's a new column actually on each of the posts, and then another column on the opposite side, identical to the one right there. But everything has been framed together. The existing beams are still there. There's just new beams adjacent to all of the beams, and they've been framed around. A couple of projects where we place beams inside of a wall to hide them, make sure that parking was maintained. Here we have another building that had 3 soft story lines, but in this case, instead of using frames and steel in each direction, the 2 short directions actually are using shear wall design rather than steel. Just the architecture of the building allowed for that. A couple more. Of course, you can leave the beams exposed depending on your preference, and just need to be painted. Sometimes it looks quite nice. Sometimes it doesn't fit with the building. this case, actually, they were a little bit more concerned about parking space rather than aesthetics. So that extra inch of stucco, they decided to do without and just leave the beams there. An example of we're always able to maintain the functionality of the building. If you have garage doors, they should be able to be left in place. Shouldn't be damaged or virtually never a reason to do so. Another example of the beams here. And then this is a shake table test. So what we have here is a short video of two buildings, one retrofitted and one is not. And this is a huge shake table test that they performed in Japan. What it is a giant table. It shakes and mimics the movement of an earthquake to determine, how these buildings are really going to fare. So I'll let you decide which one has been retrofitted, but it's kind of a nice way of getting an idea of how these buildings will perform in an earthquake. These buildings are more what you might see in Northern California and the San Francisco area type, but both are technically soft story structures and should perform very similarly. And so that's a little bit of an extreme, but and not meant to scare anybody, but essentially that's what you're doing. So these retrofits do make a huge difference. Soft story structures are everywhere. It's really important to keep an eye out for them, and extremely common. And at this point, please feel free to ask any questions, or if you'd like to go back to any area that was glossed over, or any other building types that maybe you have experience with and have questions about, or wondering how to evaluate or go about understanding what the cost might be associated with those, feel free to let me know. If you want to unmute yourself or type in any questions in the chat, I'd be happy to take those. Looks like not too many. All right, great. Well, thank you all for joining me today. If you have any questions, follow-up questions, or run into any buildings that you're concerned about, or have questions about whether or not it's been retrofitted or needs a retrofit, please feel free to use this as a resource anytime. I'm sure Stephanie can send you a copy of this presentation as well, or you can access it on their website. As well, if you'd like, please feel free to, you can send me an email and I can give you my contact information and make myself available to you if you have any questions later on. My email address, well, we can probably share it with each of you directly, I imagine. Is that right, Stephanie?
Yeah, I can send the information, or if you have it on a screen or a slide, you absolutely can share it now. That's not a problem.
Sure. What should I do? Actually, maybe I can put it in the notes here.
Oh yeah, you could type it in the chat, and that way everyone can access it, or I can send it to people as well.
Sure. Sounds good. So no questions. Anybody at all care to ask? Feel free. If not, then it's been a pleasure, and thank you very much for joining us.
Thank you so much, Jared, for sharing that information with us. It was really insightful. I loved this video at the end. It's crazy that the difference that it makes. But we really appreciate you and the information you shared. And thank you to everyone who joined us as well. We hope you have a great rest of your week.
Thank you very much.